Hello, Communication 250. Today we're talking about audio recording. So, what is audio? Well, as we talked about last time, whenever we are looking at audio frequencies, generally speaking, the audible audio frequencies are between 20 hertz and 20 kilohertz. Um, Now, if you'll look just after that in this chart, you'll see that we do have a list of the standard audio sampling frequencies. And we do also, we go up farther than this now, actually. This chart's a little old, but generally speaking, like, what is it? I think it's actually up to 196 now. But anyway, um, so we have, if we're talking about CD sampling frequencies is usually 44.1. When we talk about an MP3, it's usually 196. Um, so we uh, we do have a lot of a much higher sample rate now with audio frequency sampling. And of course, you can see your low, mid, and high frequency ranges on here, as well as the AM and FM radio, cell phones, and TVs. So you can see where they transmit, and ultra high frequency TVs and wireless microphones, those kinds of things. And of course, this one, since we're mainly talking audio, they stop at the visible light spectrum. Oh, one other thing, whenever you look at this, you'll see that the the AC line voltage, so AC and DC are currents for electricity, and these frequencies, the AC line actually is in the audible spectrum. So sometimes whenever we're looking at some kind of interference with your audio, it may be something where you have an electrical frequency issue. Right, moving on to audible frequencies. What can we hear? Well, again, the average person can hear between 20 hertz and 20 kilohertz. And we might notice volume changes at 1 decibel, but 3 decibels is going to be the average smallest noticeable difference. And animals like bats, dogs, cats too, probably also hear much higher or additional frequencies compared to what we hear as people. Now, when we're talking audio, um, we are looking at sound waves. So, sound moves in a wave. As we talked about, it is measured in amplitude as well as its frequency. Amplitude, of course, refers to the pressure. Uh, Generally speaking, when we look at audio, there are going to be lots of different frequencies happening at the same time. But when we are talking about a pure tone, so something that is just one sound, it is going to appear as a sinusoidal or sine wave. Yay, we get math in here too. Isn't that fun? Uh, Most sounds will include harmonics, so additional frequencies. That's why they usually don't appear as this like perfect wave that you see on your screen. Uh, but generally speaking, when we're talking about sound, it works in a sine wave. And an audio signal is different from a natural tone. This is an audio signal is an electrical representation of a sound. So it isn't the exact sound. It's actually taking samples of the original sound and recreating it as close as possible in the um, in the program that you're using. So it's recreating it using the electrical representation. Now, the wavelength is the physical distance covered by one complete cycle of a given frequency. And if you look here, you can see that we have one cycle measured out for you. And that again is going to start at our zero line, go up however far it's going to go up. So whatever the amplitude is, and then it's going to cross the zero line again, go down, and then come back at the zero line. So this whole thing is our wavelength. And whenever we talk about amplitude, amplitude is the strength or pressure of an audio signal measured in decibels. Uh, this is going to be positive and negative. So the positive and negative height of the wave. Whenever you look in your DAW program, the digital audio workstation, you'll see that there's like a zero line on there. And whenever you record, you should see things moving in both directions from that zero line. So there's always going to be a line in the middle of your whatever you're recording, and you should see things going above and below it. And that measurement of how far above and below is the amplitude. And again, that is actually pressure, even though we refer to it as volume. Now, one way to think about it, if you've ever been to a club where they were playing music and it was just so loud that you could see the speaker moving or you could feel it in your clothes, or if you've been outside whenever a vehicle passed and they were playing their music so loud, um, that you could feel it, that is what that kind of pressure feels like. So it is actually pressure uh, that's happening. Now, frequency is how often a sound wave repeats in 1 second. And this is measured in hertz, like I said, or it used to be abbreviated cycles per second, CPS. And that is what you're actually measuring whenever you are finding out how many hertz something is. Um, so if you look at the chart, you can see the they're showing you how far your wavelength is traveling, and you're finding out how many cycles are happening in 1 second, and that will tell you the frequency. Now, another thing you want to think about when we talk about audio is phase. And phase is the time relationship of a sound signal, which is expressed in degrees. So, if you look at this example, you can see that the beginning is 0 degrees, right? And the first apex happens at 90 degrees. The midpoint is at 180, and then the next point is 270. That's the nadir, the bottom. And then we have an ending at 360. And so one cycle of a sine wave is going to be 360 degrees. Now, it's important whenever you're reviewing your audio, more so when we're talking about music recording, but if you have out of phase waves, they can cancel each other out and result in a lower overall volume. So if you have one that instead of having its apex here, it actually has its nadir and goes down and then back up and over, it would reduce the overall volume by half. So you want to, again, this is part of why whenever you take music classes, they tell you you need to be in tune. This is because you have frequencies that are too close but aren't quite where they need to be. And if you're out of tune, then it can actually make everything lower in volume. And I mean, it sounds bad. Now, to review, what do you call the strength or pressure of an audio signal? That's right, it's the amplitude. Amplitude. So, how do you record audio? Well, you use something called a transducer. And transducers convert energy from one form into another. And things like speakers and microphones are both transducers. They are converting the energy that is around them into another form. Um, so the eardrum is actually a natural transducer, and that is because our eardrum has a little it has a little tympanic membrane in it that you are using, that your body uses to convert the pressure and the frequencies that it experiences into signals that your brain can understand as sound. And like I said, we have our own versions of these input transducers and output transducers. And here's a quick look at the tympanic membrane right here. So you can see in the auditory bones and canals and the cochlea and all those things that make your ears work. Now, input transducers, that's our microphones and guitar pickups. They're converting acoustic sound, so the sound that is out here in the world, into audio signals. Specifically, nowadays, we are looking at digital audio signals. So, whether you're playing an electric guitar or a guitar with an acoustic guitar with a pickup on it, um, that pickup is going to transfer those acoustic signals. It is going to convert them into audio signals, which are then read by whatever system you have. And then they go into your digital audio workstation. And then eventually you are going to send them back out into the world using output transducers. These are usually loudspeakers, headphones, those kinds of things, whatever it is that you're using to hear them with your ears and experience them in person whenever you are not listening to an acoustic instrument. So output transducers convert audio signals back into sound. Now, usually there's some signal processing that goes on in between using the microphone and putting it back out in through a speaker or through headphones. And this processing happens in the console. Um, there's some preamplification that happens. A console increases microphone volume to a standard level. And you'll notice that some consoles do have something called phantom power available on them. That's for microphones that require a little extra oomph whenever they are picking up a signal. And then we also have things called equalizers, equalization, and this is a way for you to balance the tones that are happening, the highs, mids, and lows in each audio channel. Because, like I said, we are experiencing lots of tones whenever we are listening to audio. So, you want to make sure that they are balanced and easy for your audience to hear and appreciate. And This kind of mixing can happen on each audio channel or through a master channel. And then, of course, we have mixing. So this is where we're taking our microphone input and other audio signals and mixing them together into a single signal, which runs through the master channel, which is normally used for our eventual output. Now, here's an example of a broadcast console. And broadcast consoles are going to be a lot simpler than the types that you'll use if you decide to go into music recording. Um, and this is because we want to be able to quickly put together sound bites and get it back out on air. Or you could be dealing with a live situation where you have people calling in. Call-in shows are something where you want to be able to quickly access each of your options and provide any live mixing that may be required. Now, broadcast consoles allow you to edit your audio, and usually nowadays we're using a digital audio workstation. You don't have to worry about mixing it, like having a bunch of different tape inputs and cutting things, physically cutting things and splicing them together and that kind of stuff. So nowadays, using digital audio workstation, microphones can connect directly into the console, or you might have something else like a preamp that you're plugging into before you go into the console. Um, and you also will notice that we have more than one or two lines here, and that's because we have some auxiliary lines, and these extra channels might be used for monitors, so ways for the talent to listen to what's going on, or maybe you want to run a special effect through a particular channel and have it queued and ready to go. This is usually a little more with whenever you're mixing music stuff, but it might be something that you'd use in broadcast too, but sometimes you'll want that extra channel for monitors again or for special effects. Now, here's an example of a music recording console. Now, they come in a lot of different shapes and flavors. Some of them are more compact. A lot of them, like PreSonus, I know makes a few boards where you can click between different versions of your board, so you can like save a lot of different channels on there. Um, and this is important whenever you have maybe, 20 inputs that are happening, or if you are working a live show where you have a lot of different bands performing, maybe you want to uh, preset some things and save it and have it ready to go. And of course, they are used in the studio as well whenever people are mixing and mastering their music. Now, whenever you're looking at a board, the console or the board, you want to, of course, identify your different channels that are on here. And the first line is almost always going to be a mic line, especially for broadcasting. And by first, I mean the one all the way on the left. If you look at the picture, I put a little box around it for you. And this controls one audio input. In this case, it's the mic line, and you can see they had one for a CD too. And then they had a DAT right here as well. Um, sometimes they would have things like an 8-track or reel to reel or something too, but we don't use those things. And nowadays we're normally focused on a mic in, and then you might have a channel where it's connected in your digital workstation where you can increase or decrease the volume for different tracks. Now, the master channel will control your final mix. And again, that means it a lot of times it's really more about the volume, but you might want to tweak your whole mix with the highs, mids, and lows on it. Maybe you need to run a special effect through everything that you did. So whenever it gets mixed, it might go through one of those aux channels we talked about and then into your main output using that special effect. But again, your main is going to include all of your all of your inputs. So if you increase the volume here, it's increasing it for everything, not just your microphone or not just your background audio. Now, we also have these things. If you'll notice, each of the boards had at least a few of them. These are called potentiometers or pots, and they control different aspects of a channel. The gain knobs at the top, if you look right here, they say gain. Gain refers to volume. Now, be careful if you're using these to increase your volume. It can cause distortion. Make sure that you're using the correct mic, that you have a preamp where you need it. So sometimes the gain will control your preamp for that channel too, but you want to make sure that you increase the volume enough for things to be heard at the appropriate level, but sometimes you want to mix down as well. So you might have things turned up a little too high. This happens a lot, especially with background audio, where you need to turn that down a bit and that mix down instead of mixing up. And we also want to look at your pans. So adjust your, whenever we talk about panning right or panning left, this is not a Peter Pan thing. If you look at this little knob right here, um, all of these are going to the left. Uh, I'm guessing based on how most boards work that it's because this is a mono out that they're running into something, and usually the left is going to be the mono channel. So that means if you don't have stereo, you have mono. It's like a single channel for it to go out. Um, excuse me. And so you want to make sure that you have everything panned appropriately for your projects. All right. Now that we've gone over some of the basics, think about, what do you want to record? What brings you to this class? Are you looking to work on your audio to go along with your videos? Or are you looking to create some audio media that you're going to post online? Whatever it is, let me know and I'll do my best to help you with it. In the meantime, uh, when you're done reading chapter 1, please continue on to chapter 2, the studio environment. And I'll see you next time.